Good morning. I am Dr.D.Sathya, working as Assistant Professor in Department of Chemistry, SNS College of Engineering. Today, we are going to discuss about polymeric material. A thermosetting polymer, which is also known as the thermoset or thermosetting plastic, is a consisting of cross-linked structure or heavy branched molecules. So plastic is one type of the polymer. It's a material consisting of any of wide range of synthetic or semi-synthetic organic compounds that are malleable. It can be molded into a solid objects by applying a heat or pressure. So this resistance to corrosion and chemicals and also the very low electrical and thermal conductivity, high strength to weight ratio, colors available in wide variety of the transparent, resistant to shock, good durability, low cost are easy to manufacture. So thermoplastics substance is easily a synthetic resin that become plastic on heating and harden on cooling. So they are able to repeat this process. So thermoplastic or thermo-softening plastic is a plastic material, a polymer that becomes malleable or above the specific temperature solidifies upon the cooling. The types of the plastics amorphous thermoplastic polymer and crystalline thermoplastics. Amorphous thermoplastic polymers mostly transparent or translucent, low tendency to creep, good dimensional stability, low tendency to wrap and tendency to brittleness, and low chemical resistance, sensitive to stress cracking. In crystalline thermoplastics is a translucent and opaque, good fatigue resistance, tendency to toughness, and good chemical resistance, good sliding characters, and wear resistant. So the thermoplastic properties, it's a very lightweight. So one of the main properties of thermostatic plastics or polymers is that they are hardened during the molding process, and after the solidifying they cannot be softened. So the thermoplastics are very lightweight and density 9 to 2 gram per cc. Some high temperature thermoplastics and material can withstand the temperature extremes of to 600 Fahrenheit, while others retain to the properties minus 100 Fahrenheit. So most of the thermostatic material is excellent insulators, both electrical and thermal. Multiple cycles of heating and cooling can be repeated without serve the damage, allowing the processing and recycling. So they are soluble in certain solvents and swell into a presence of certain other solvents. So the loss of the advantages here because it's a high strength, lightweight, relatively low processing cost, energy efficient both in their manufacturing and processing. Thermoplastics can replace the metals with the considerable weight saving and providing the proper care in taking a design. The most thermoplastics have been better properties than comparative the metal and well tolerate larger deflections than the metals without the deforming. Some disadvantages also there in some thermostatic polymer. Thermoplastics melt, some degrade in direct sunlight under the high UV light levels. Many material have poor resistance to hydrocarbon, organic solvents and high pore solvents. So many thermoplastic material, especially composite, and tend to fracture rather than deform under the high stress level. So once heated and molded the plastics, it cannot be reheated, remolded. It can be reheated and reformed. Consequently, they tend to be difficult and recycles. For example, rubbers, additives, epoxy, syntax gloves and erasers and baking molds, balloon and insulation, electrical cables. So in epoxy, water and heat resistance, polyurethane, tough and water resistance form used in insulation material, floors and roofs. The scratch resistance are very good electrical insulator, the lightness and toughness. So what are the advantages and disadvantages of plastics? More resistance against the high temperature and hard and rigid, the excellent aesthetic fineness and high mechanical property, cost is very effective and excellent dimensional stability. So cannot be recycled in this way, main one of the disadvantages, and much more difficult to surface finish, cannot be remolded or reshaped. Poor thermal conductivity for some housing replacements. The rigidity of the material can result the product failure when used in a high in vibration applications. So these are the thermoplastic and thermostatic plastic of the examples. Here no links between the polymer chains and helps to movement. In thermostatic plastics, the links between the polymer does not sustain movement in between the thermostatics. So these are the difference between thermoplastics and thermostatic plastics. So now we are discussed about what are the thermostatic and thermoplastic polymers. So these are the main keywords. So thank you.